Okay. That was number 37. 39 is like 35. 41 is different. Let's look at 41. And 43 would be different too because it's got secant and tangent. Problem with those are I don't have those functions anywhere. I got cosine and sine, tangent of course, but secant is 1 over cosine. Now, if I multiply both sides by cosine theta, I'm going to get r cosine theta is equal to 3. And r cosine theta is equal to x. So this would be x equals 3. So the graph of it would be a line at x equals 3. Now consider how easy that was to switch to rectangular form and graph it, versus if I tried to do a t-chart based on secant theta. You know, and as you saw, I screwed up the one I did do. But if I tried to create that, that'd be nasty. So that's the idea. Is sometimes you find it easier to be in rectangular form. Sometimes you'll find it easier to be in polar form. And okay, let's take a look at 43. I don't know how to work that one. This one I could see. Secant theta, tangent theta. Now, tangent theta doesn't really bother me because I can rewrite tangent theta as y over x. So I'll leave that alone. What does bother me is the secant. Just like the previous problem, I could rewrite that 1 over cosine. Multiply both sides by cosine, and you get r cosine theta is equal to tangent theta. Now, r cosine theta is x, and tangent theta is y over x. Now, if I multiply both sides by x, I'm going to get x squared equals y. Which is our parabola, isn't it? I don't think you need to see these. I think you got these. Except, it does say find an interval for theta over which the graph is traced only once. Because that leads in the next section. You know, a lot of problems you don't necessarily, some you can do it. But I didn't mean to do that. Canvas size. There you go. Okay, so if I'm trying to find the area of this, if I went from 0 to 2 pi, what would be wrong with 0 to 2 pi? They're at the same place. So it's like going from 3 to 3. And so oftentimes you don't want to go from 0 to 2 pi. Think, okay, I'm going to cover myself. I'll cover all my bases. I'll go from 0 to 2 pi and be fine. That's what they're indicating, why they're saying this. They say find an interval for theta over which a graph is only traced only once. Just assuming you can go 0 to 2 pi, it just doesn't work very well. I wish I was good enough to see these. Let's look at 49. I can't eyeball them and see that this goes from 0 to pi over 2 or 0 to pi. 2 divided by, parentheses around the bottom, 1 plus cosine theta, number 49. And then graph. Looks like a parabola, doesn't it? But we'll zoom out and see. The problem with this is if you trick trig of some sort, they told you in trig to do a zoom z trig. But if I did a zoom z trig, sometimes it gives me a good graph, sometimes it doesn't give me a good graph. Yeah, that's what it should be. I think. Yeah. But sometimes it gives you a good picture, sometimes it doesn't. If I did a zoom and did my z standard, it's more like that. But you're right, the question is what's happening over here. So if I do zoom, zoom out, press enter. You got a circle? Some of them may be circles. I'm not good enough looking at these to see. But no, you did something wrong. Here's how you should put it in. Oops, maybe. It's on Never Never Land. There it is. All I can tell you is try different ones. Try to do your 6. See if that gives you a picture. If it's shifted over, then you may not be able to see it, depending on what numbers are there. So you may have to zoom out and so forth. Another thing to keep in mind is if you go to your window. So if you press your window, if you've ever been here before, all they normally have is x min and x max. Here's where you can tell it to go from 0 to 2 pi for your angle. So if you have this set by accident, and maybe you're playing from a previous problem, and you have this going from 0 to pi over 4. Like that. And then when you go graph, every problem from there on is screwed up. So it takes awareness of what that window setting is and so forth to do these correct. You go back to window, go down to your theta max, and you type in 2 and then pi, which I think is second caret. I don't know. Did it set back the theta also? Okay, good. I didn't know that, so that's good to know. Okay, now if I press graph, what they're indicating though is you need to understand more about what thetas should be over without traveling twice or 3 times or whatever. If I press my trace, you see theta is equal to 0. If I do my right arrow key, look at where my cursor is going, the direction it's going. Well, it's interesting because it circles back around. No, it doesn't circle back around. But there is a place where it's undefined where the bottom part is equal to 0. And then it starts circling back around. And then this goes to probably, you can actually hold that down and it does it fast, but 2 pi. Now, I may not want to go from 0 to 2 pi, though, because sometimes that causes us problems. Let me hold it down. Okay, get back out there. Undefined is right here. It's undefined at pi. So maybe I'd want to go from 0 to pi because that's the top part of my graph. And then multiply by what? 2, if I'm trying to find my area. So you can use symmetry to do that. Now, some problems it'll work just fine if you go from 0 to 2 pi. We're going to see the next section is all about setups. You know, the finding the integral is a trivial part, but the challenging part is doing the setup. Let's look at number 51. 5 cosine 3 theta divided by 2, and I'll press graph. That's interesting. Let me come here and change this to 4 pi. And then press graph. Yeah. 4 pi would take me back to my starting place, wouldn't it? Now, more or less, keeping in mind that this is a rectangular setting, but do those, and we'll see the test for symmetry, but do those look symmetric? Yeah, assuming they're symmetric, there's how many of them? 6. So if I find one of those leaves and then multiply my area by 6, then I'll have the area for all of them. Now I'm going to zoom in on just a little piece here. This is where it's nice if you had that little circle so you can see it graphing. Maybe you have to be in Polar to see it. Let's see. I don't know if I tried that the other night. I don't know how I can now remember where that's at, or if it's not even there, maybe. Okay. I'd almost, I think I tried this on a problem earlier. I don't think it worked. But if it's 4 pi and there's 6 of them, if I take 4 pi divided by 6, 2 pi over 3. Let's try to change the window setting such that y max is 2 pi over 3. And graph. Nope, I didn't get the piece, did I? How about pi over 4 or pi over 2? Pi. Sorry. I choose something bigger. Okay, so let me zoom in, press enter. Too much. Might be able to see it though. If I did trace, oops, right, go the right direction. Okay, so that's the start of my leaf right there, right? Of course, the question is what in the world's 1.047, if anything? Equals pi divided by 8. Pi divided by 6. Not even close. It's over on that side. Something greater than pi over 2. pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Oh, I'm just like really hitting that. What's that? Pi over 3. That's it, pi over 3, isn't it? It's probably nice to have those written down. So I could start my limits of integration at pi over 3, couldn't I? Question is, where does it stop? If I went around, stops there. Oh, I recognize that one. 3.14, that's pi, isn't it? So my limits of integration here would be pi over 3, 2 pi. Find the area based upon that and multiply by 6 to get those 6 leaves. Don't worry too much about that. They're just wanting you to really focus on the tracing part. Okay. Slope in polar form. Boy, this is a challenging topic here. I don't know if I was just tired or what, but I was having a real hard time getting this correct. So I'll probably just stick with the easy one and leave the hard ones for you guys to do. They're not hard. That's why I don't know why it's not total. Okay, so let's look at number 63. R equals 2 times 1 minus sine theta. And instructions say to find dy dx and the slopes of the tangent line shown on the graph of the polar equation. And I'll focus on 2, 0. I'll do the hard one. Now from your formula, it's pretty easy. You need f of theta. The r is always going to be your f of theta. So keep that in mind. You're also going to need f prime. Two remains. The 1 would go away. Derivative 1 is 0. Minus, and then the derivative of sine is cosine, so that's a negative cosine, or negative 2 cosine theta. Now at that point, we're ready to plug it into this formula. Dy dx is equal to f of theta cosine theta plus f prime of theta sine theta negative f of theta sine theta plus f prime of theta cosine theta. So if we plug in what we found, f of theta is 2 times 1 minus sine theta times cosine theta plus f prime, which is minus 2 cosine theta times sine theta. The negative f of theta, so negative 2 times 1 minus sine theta, plus f prime is minus 2 cosine theta times cosine theta. I'm gonna double check myself in CalcChat since I screwed it up this afternoon. It's not hard as you see. Just I don't know why I was messing that up. Where's CalcChat? So I closed it. There's CalcChat. And this is number 63. Two. Over here, 2 cosine theta. 2 cosine theta times 1 minus sine theta. Okay. Minus 2 cosine theta sine theta. Okay. That, and then. Okay, so I didn't screw it up this time. Now, to evaluate this, dy dx gives us our slope. We're given a point, and they're specifically telling us that it's in what form is this in? Rectangular or polar? Yeah, and also the other hint is pi over 2, 7 pi over 6, 3 pi over 2. These look like r and theta, don't they? Specifically, since this is at 3 pi over 2, that one's a little harder, 7 pi over 6. So yeah, these are polar, which means 2 and 0, theta is 0. So if I plugged in, my theta is equal to 0 for here. 2 times 1 minus sine of 0 is 0. Cosine of 0 is 1. Minus 2 cosine of 0 is 1. Sine of 0 is 0. Down below, negative 2. 1 minus sine of 0 is 0 times sine of 0, which is 0. I feel like I'm screwing it up again. We'll see. Cosine of 0 is 1. Cosine of 0 is 1. One minus 0 is 1, times 2 is 2, times 1 is 2. That drops away, this drops away, 2 over negative 2, which gives us a negative 1. So my slope is negative 1 at that point. Clear as mud how to find the slope? Yeah, this section is taking me longer than I thought. We're not going to get to the next section until next time. Now these ones, I'd put this here. I won't show it because I think it's pretty self-explanatory. I may do the dy dx just so you see it. Or is that the same one we did over here? 1 minus sine theta. Oh, it's easier. But in the horizontal tangency, you set the numerator equal to 0 and solve. And your vertical tangency, you set the denominator equal to 0 and solve. So, look on number 69. Now, one thing that really threw me on this one, then I remembered from Calc 1, you guys may remember it right off the bat, is you cover it in Calc 1, sort of, kind of mention it, if your instructor did right by you. Now, first, find dy dx. That goes back to this formula right here. So you find this. So f of theta is equal to 1 minus sine theta. F prime of theta is going to equal to negative cosine theta. dy dx, we got f theta, which is 1 minus sine theta, times cosine theta, plus f prime, which is minus cosine theta, times sine theta, over negative f of theta, so negative 1 minus sine theta, sine theta, plus f prime is minus cosine theta, times cosine theta. Okay, horizontal tangent c set to numerator equal to 0 and solve. So if I set that equal to 0, I got 1 minus sine theta cosine theta minus cosine theta sine theta is equal to 0. Now, I got two groupings here. I got this group and I got this group. They both have a cosine theta in common, so I can factor that out. And that's going to leave me 1 minus sine theta minus sine theta equals 0, which gives me cosine theta 1 minus 2 sine theta equals 0. If you remember these, if you saw these in trig equations, we got this factored now, so I set each factor equal to 0. So I set cosine theta is equal to 0. 1 minus 2 sine theta is equal to 0. This one is solve for sine, and I get 1 equals 2 sine theta, or sine theta is equal to 1/2, and drop to 0 there. So for this one, if I think about where cosine is equal to 0 at, as I start going through my unit circle, cosine is equal to 0 at pi over 2. I keep going around. The next place where it's equal to 0, 3 pi over 2. Sine of 1/2. This is a little bit harder. I have to think about this one. There's two places where sine is equal to 1/2. Right here, which is pi over 6, and 5 pi over 6. Oops. I looked at CalcChat just because I like to make sure I'm showing you the right technique. And what is it? 69. They come up with pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. So that's what you get when you solve the equation. But then they say the horizontal tangents, they use the 3 pi over 2, they use the pi over 6, they use the 5 pi over 6. They dropped the pi over 2. And at first I was looking at that, what? How about I did drop the pi over 2? And I did, because there's no explanation. And they'll say, well, we dropped the pi over 2 because, let's graph this. Then maybe you can tell me what's wrong. Okay, come over here. 1 minus sine theta. And we'll do zoom 6. Can't really see it, but if I do a zoom in, zoom box might have been better. Okay, maybe I still don't understand it. But if I do a trace, now there's theta is equal to 0. I press my right arrow key. The one they ignore is this one right here. 1.047. That's one I struggled with finding, I think. Is that pi over 2? There's pi over 2. I'd have to zoom in for you to see it. Let me zoom in again. Zoom in again. It's just not going to. I guess that's about as good as it's going to get. The trace. We're looking at pi over 2, which is more or less right there. Why did they drop the answer? From Calc 1, there are certain places where the derivative does not exist. Remember an absolute value? At that sharp point, your derivative doesn't exist. Remember them saying something about a cusp? C-U-S-P? Yeah. You probably heard it. They maybe mentioned, then they didn't do anything with it, because you don't do anything with it until Calc 2. This is a cusp. A cusp is when it's curved in like that, and you got a sharp point. The derivative does not exist there. That's why they dropped the pi over 2. So. Now, by the way, how would I get r if I got theta? Take the 3 pi over 2 and plug it into my original problem, right? 1 minus sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. 1 minus a negative 1 gives me a positive 2, and that's where they get this at. Does that make sense on those? Let me solve this one, just because some of you look kind of hazy on trig equations. Let's see if I can figure out how to go back without destroying my original equation. Original slope, I should say. Okay, that was the top part. The bottom part is what gives us the vertical tangency. And it says set the denominator equal to 0 and so on. Okay, so set the bottom part equal to 0. Minus cosine times cosine is cosine squared equals 0. Why do I get that parentheses there? Okay. So negative and a sine gives us negative sine theta times 1 minus sine theta minus cosine squared theta equals 0. Negative sine theta times 1 is negative sine theta. Negative sine times negative sine is a positive sine squared minus cosine squared. One of the tricks of solving a trig equation is to get everything with the same trig expression. And cosine squared, sine squared plus cosine squared is equal to 1. if I take the sine squared over there, cosine squared is equal to 1 minus sine squared. So I can rewrite the cosine squared here as 1 minus sine squared. So then I got negative sine theta plus sine squared, negative 1, negative negative positive sine squared theta equals 0. Sine squared plus sine squared is 2 sine squared minus sine theta minus 1 equals 0. Now this can factor. This is quadratic. I assume it can factor if I didn't screw up. If you have trouble seeing it, replace the sine theta with p, another variable. So that's like 2p squared minus p minus 1. Factor this. Squared minus 2p plus p. So it factors this way. So this would factor the same except for I replace the p with sine. So this becomes 2 sine theta plus 1, sine theta minus 1 equals 0. Then I got 0 on this side. I factored the other side. I set each factor equal to 0. So I got 2 sine theta plus 1 equal to 0. Sine theta minus 1 equal to 0. 2 sine theta is equal to negative 1. Sine theta is equal to negative 1/2. On this one, sine theta is equal to positive 1. If I look where sine is equal to 1, there's only one place. That's pi over 2. If I look at where it's equal to negative 1/2, that's like this piece right here and this piece right here. It went down too far. This is 6 pi over 6. That's 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 5 pi over 3. I'm not very good with quadrants 3 and 4. I think that's right. Or is it 11 pi over 6? It's 11 pi over 6, isn't it? Jeez. Because if this is pi or 6 pi over 6, then this is 1 more pi over 6. If this is 2 pi or 12 pi over 6, this would be 1 less, so that would be 11 pi over 6. And then, assuming none of these are cusps, you'd find the r and go from there. If you've never seen trig, it's probably completely alien. But I do have videos out there. If you go to Math Heals, go to trig and watch trig equations, you'll see tons of trig equations. Let's see. Now this says tangent lines at the pole. If f of alpha is equal to 0 and f prime of alpha is not equal to 0, then the line theta is equal to alpha is tangent at the pole to the graph of r is equal to f of theta. This involves solving. Let me get back there. Where's the book? They don't even give you an example. Since I don't want to take time to show it, so let me show 73. R is equal to 5 sine theta. Well, let me go ahead and work it. Calculate doesn't look like it's right. That's interesting. If we got time. This is not a bad formula, even though they don't have any examples there. The reason why it's not bad is it helps you to understand notation. And if you're going on take another mathematics courses, understanding what notation is saying is half the battle. Keep in mind, R is f of theta. Now, what do you think they mean by f of alpha is equal to 0? Where in the world does alpha come from? Right. So I'm going to take my my function, and I'll set it equal to 0 and solve it. Now I assume they mean between 0 and 2 pi. Well, it has to be because we're talking about the polar. Never mind. So I divide both sides by 5, and I get sine theta is equal to 0, which is 0 and pi, right? So if I were to plug in, for example, f of 0, where this is my alpha, that would give me 5 sine of 0. Sine of 0 is 0 times 5 would give me 0. That would match the formula here. We just found an alpha that gives you 0. Now the question becomes if pi is even necessary. And I don't know if it is. Let's go to our graph. Okay, so put in 5 sine theta. Push graph. Okay, let me do a zoom 6. Send it back. Now let me do a trace. There's 0. And I'm wondering about pi. If I do my right arrow key, halfway through the circle, I'm at pi over 2. Pi takes me back to my original point, doesn't it? So basically, these would be the same, wouldn't they? 0 and pi. So the only one I need to consider is 0. This is why understanding that trace. Now, these were a nightmare before the graphing calculator. Because you'd have to do those T-charts, you'd have to build it, see where it ended, and so forth. And this has simplified it so much. Okay. Now, the second part. What does this imply we need to do? Yeah. Not set equal to 0, but plug in 0. Because it's, we'll find a derivative first, then we'll plug in our alpha we just found. And then we're going to see if it gives us 0 or doesn't give us 0. So, f prime is going to equal to 5 cosine theta. We're proposing that alpha is equal to 0. This is what we're thinking. So if I come up here and I plug 0 in, I get 5 cosine of 0. Cosine of 0 is 1 times 5 is 5. The question becomes, is that not equal to 0? It is, isn't it? So that meets the criteria. Then that says that the line theta is equal to alpha is tangent at the pole. So theta is equal to 0 will be our answer. And you can look in the book and read about the poles and so forth. We're running out of time. Because I want to show these graphs. There was that one graph that had the cusp that I kept zooming in on. You may have been wondering, why is he zooming in so much? I was trying to see if there's a little circle here. Because when you graph like this right here, it goes around and then comes down here, meets at a point, circles back around and comes back to the point. So it does a little loopy-loop thing there. When I kept zooming in, I couldn't see it. That told me that it was there was no circle there. That's called a limacon, if I'm saying that right, with the inner loop. Cardioid is the heart-shaped, and I think cardioid but rotated was what we saw. Dimpled limacon, interesting. Not every book has that one. Convex limacon. If you're graphing them by hand, knowing generally what it looks like really helps you on these problems. Now here's cosine, and n is equal to 3. If you got okay, now I remembered. If n is odd and you got cosine, then your number of leaves will match whatever numbers in front of your theta. So if I have 3 theta, I'll have 3 leaves. If I have 5 theta, I'll have 5 leaves. If I have 7 theta, I'll have 7 leaves. If it's even, like n is 4, like you got 4 theta, you have double the leaves. So you have 8 leaves. So if you had a problem that was 16 theta, how many leaves would you have? Double it. 32. So you'd have 32 leaves. Let's see. Remember what this one's about. If n is equal to 5, so it's odd, we have the same number of leaves. If it's even, we have double the leaves again. So n is equal to 2, like 2 theta, we'd have 4 leaves. If n is equal to 4 theta, you'd have 8 leaves. That's important to understand when you're getting ready to find the derivative. There's one of them in the next section that has so many leaves. I was trying to count how many there were, and it was really hard. By having this chart here, it helps you to figure out, what are you trying to find? How many leaves? What do you need to multiply by? Because there's symmetry on this. All I have to do is find the area of one leaf and then multiply by 4 for this example. All I have to do here is find the area of one leaf, multiply by 5 in this example, and so forth. One more minute. Quickly. Nothing exciting there. Circle, circle, lemniscate, except for watching me butcher it and say the name wrong. But again, that shows you more shapes. We're out of time. 10.5 we'll work on Tuesday. We can still have a test on Thursday if you want, or the following week. I'm open. So think about it, and I'll put it up for a vote on Tuesday. And whatever you guys decide, I'm fine with. We're done.